All right, stats. Here we are for your video for Wednesday's coding. Okay, so you're doing this in class on Wednesday. I'm not with you, but I trust that you and can do this. You guys can help each other out. Again, we're just doing some data entry. So I'm trying to make a video here at my desk in my room the day before. A little cramped for space, but this is what you were supposed to have ready. All right, you're supposed to type in x1, x2, and y, just like this. Okay, now, you know you did that correctly if you look over here. Now, my number's gonna be different because I did all, come on now, I did all 88 towns. So I know that I'm correct because for x1, I got number because their number is 1 to 88. Same thing with x2, same thing with y. You need to make sure that, you know, you maybe have made some errors and you correct them, but you need to make sure that you're 1 through 80 on all these. It got to be 1 through 80 or anything we type in today is going to be wrong. You're going to get error messages. So you need that done by Wednesday or else we're sort of in trouble, okay? 1 to 80 on all this or this will not work today. All right, so here's what I want us to do. We can do all this. All right, so I want you to type in, see what I did here? So mean y, and you got to make sure, again, it's case sensitive here, case sensitive. So got to make sure what you type into R is exactly what you did before. So I called it capital X1, I called it capital X2, I called it capital Y. If you use lowercase x1, lowercase x2, lowercase y, then you got to type the same thing into R. It's very case sensitive, so I'm going to kind of show you what that means here. Now, I've already typed this in, but I'll go down here and I'll type it again. So if I want mean, I'm going to start typing MEA. Okay, look, mean pops up. Mean pops up, so I'm going to click mean, and I'm going to type in now, I'm going to type in capital Y. I'm going to type capital Y, and then I'm going to hit enter. That's my mean Y. So that's of all these towns, that is the average of the median family income. Now, take a look at this. If I were to type in mean, and I were to type in lowercase y, it's going to report an error, object Y not found. That's because if you go back to my values here, I told R that Y, my median family income, was capital Y. So when I try to type in lowercase y here, it's going to say Y is not found because I didn't denote it as Y. All right, so write that. Just have that down. Maybe write that down off to the side. Again, there's going to be a lot of stuff you write down. You don't need to turn in. So then we're going to do what? Standard deviation. We're going to do order of Y. All right. So SD, now I think you actually just have to type in SD. SDY, so looking at those Ys, what's Y again? Median family income. All right, so I have the mean of my median family income, so then I have standard deviation. All right, then we're going to follow the same order for all these. Sorry, I already, did this a little bit ago. Order, then summary. So what I'm going to do then is, order is great because it orders whatever you want, whether they're residuals or, data points here. So I'm going to order Y, okay? So when I hit enter, what this means is the smallest Y is town 49. So if I go and I look at my data, town 49 for me, which, bad for me, I should have that in front of me. Town 49 has the smallest income. Town 19 has the highest income. Town 74, the second highest, third highest income, fourth highest income, fifth highest income. This is the lowest income, second lowest income, third lowest income, fourth, fifth. This is Litchfield right here. So we need to find the rank of Litchfield later on. Okay, so if this is like, town 88, 87, 86, 85, you can go that direction. Now, notice here when it says 1, this is starting with your first in order. Now, they always go low to high. So this is, the 21st lowest, the 22nd lowest, the 23rd lowest. So Litchfield is the 24th lowest. There are 23 towns below Litchfield here in the ranking of the 88s, actual 88. All right, so I'm going to help you with that again. All you need to do is type this stuff in today, have it, and then I'll help you analyze this on Thursday and Friday. All right, so then we're going to type in summary of Y. I'm going to hit enter. What's the summary of y? This is what we need here, all right? So I'm really looking at guideline number 5. Again, you're supposed to get this today, new sheet with, I've listed out the guidelines and how many points they're worth. You guys need to know that. So we are stating the mean, standard deviation, and the 5-number summary of each variable today. That's what we're doing here. So, I mean, we're at least getting this down. So that's the minimum. All right, that's quartile 1. That's the median. We've already given the mean, so we don't really need that. That's quartile 3, and then that's the max. Okay. All right, excellent. And then we're going to have some plots because we're also looking at guideline 3 here. We're getting that coding. So last thing here, box plots and histogram. All right, so I'm going to type in box plots. Box plot. I'm going to box plot of y. Box plot of y. Enter. Okay, so when you type in box plot, then when you go down here, you're finally going to have something. These are your plots. Okay, and we'll be able to, you'll be able to copy image. It's no big, you'll be able to copy image and paste it. Anyway, here's my box plot, right? This is a, we did those before. So what's interesting is they'll make box plots sometimes with like getting rid of that outlier, so that high one, and then they'll just show that, hey, this is the outlier, and if you remove it, then this would be the next max. So this is like the second one, and they're showing you that this is a high outlier, okay? They'll do that sometimes. Sometimes they'll remove the max or the min, and they'll make a box plot with the other data values, and they'll show you that you either have a really high outlier, really low outlier. And we're also going to show that mathematically, outliers. Okay, great. So, one last one. Histogram, right? I need to have this memorized. All right. Histogram of y. H-I-S-T. Hist of y. You see me type this in. Awesome. Off to the side, I got a histogram of y. Awesome. Looks a little skewed to the right, does it not? Great. So we're just going to copy that later. Awesome, folks. We're now going to do the same thing. We're going to do the same thing with x1. So we're going to type in mean. I'm going to type in mean of x1. Enter. Awesome. So that is the average, the mean of your high school graduation rates of all these towns. So we did mean. We're going to do standard deviation of x1. Just follow this order. All right. Standard deviation of x1. All right, what is next? Order of the high school graduation rates. Enter. Okay, that means town 77 has the lowest high school graduation rate. This is the second lowest, third lowest, fourth lowest, fifth lowest. There's Litchfield. Litchfield is pretty close to the middle high school graduation rates. Town 13 has the highest high school graduation rate. Town 30 is the second highest. Town 19 is the third. Town 36 is the fourth, and town 38, again, in mine. Some of these towns have been removed for you, or they're different. Like you have a town 38 in there. You don't have a town 88. You don't have a town 86. But that's where they are. So that's why when you label your data, it's got to be really organized. So you know who town 38 is. You know who town 50 is. All right, so then I want summary. I want summary of X1. Again, just type this in correctly today. We'll analyze it Thursday and Friday. So the lowest high school graduation rate was 70.2. That's quartile 1. It's the median. We don't care about the mean, really, because we already have that. It's quartile 3, and that's the max. Awesome. Box plots. Let's do box plots. X1. All right, off to the side, So what they've done is they removed, it looks like 2 outliers at the bottom there, and then they can kind of show you what this would look like if you remove your 2 outliers. All right. And they still put the outliers in there. They just don't count it as one of the whiskers. And lastly, histogram of X1. Enter. Skew to the left. All right, we are going to then continue on with the mean. And you can also just type in mean and then use parentheses. But if you always choose it, then they'll put a appropriate number of parentheses in there for you. So the mean, the average of the college graduation rates of all these towns, there it is. What is the standard deviation of X2? There it is. We then need to order. Need to order them. So Town 21 has the lowest college graduation rate. Town 49, second lowest. Town 41, third lowest. Town 77, fourth lowest. Town 85, the fifth lowest. Town 50 has the highest college graduation rate. Town 28, second highest. Third highest for Town 38. Fourth highest for Town 30. Fifth highest for Town 11. Where's Litchfield? Litchfield is getting close to the middle. All right, box plot. We're going to do a histogram of X2. Oh, I should have done box plot. Guys, the order doesn't matter. All right, order doesn't matter. Box plot, and you really just got to have these down because you're going to copy them. All right, so box plot, there you go. So it looks like we got a town up here. Town up here that they're thinking is an outlier given our data. And then you can always go back. This is how you see your other plots. And this is the histogram of X2. Looks like we're skewed to the right there, huh? Awesome. Okay, so what else can we type in? What else we're going to type in? It's all about now our models. All about now our models. So after all that, we're going to do high school model, residuals. We're going to order, and we're going to plot the residuals. Okay, so I would type it in just like I'm going to do. I'm going to do HS model. HS model, okay? Type it in just like that. Then you're going to use the less than symbol dash. Okay, space is an LM, linear model, parentheses. We've done this before in the baseball project. We're capital Y, and this is, I'm going to hit shift. I'm going to make the little tilde there. Y has a relationship with X1. Okay, those got to be exactly capital Y, capital X1. Then I hit enter. And nothing happens. Nothing happens. But if you go up to your global environment here, now you see high school model. It's going to say listed 12. High school model listed 12. So as long as you don't get an error message, you're going to get an error message. If you type in, if I use like lowercase x1, or if y and x1 don't have the same number of data points in them. If 179 and 1 is 80, you're going to have an error message. All right, awesome. Then I'm going to type in summary. I'm going to type in summary of high school model. You got to choose. It looks like confetti there, sort of. You got to choose that. And then I'm going to hit enter. Okay, so this is what you can start writing down. Okay, so the intercepts, that is, that's the y-intercept. So my model would be y hat equals 2769.9 x1 minus 169,325.1. That is my model. Now, my r squared value is, we're going to use for the two regular linear regression models, we're using multiple r squared. So I'm going to say r squared is 0.3468. I'm going to take the square root of that to get r. That's my correlation coefficient. I know that r is positive because my slope is positive. All right, that is very, very important. That's the second thing. Clearly write out your linear regression equation. We're talking about guideline 2, as guideline 2 right there, okay? If you need to pause this so you can hear me say something again, I'd recommend that you do that. Okay, so then we're going to do residuals, and then we're going to order them, and then we're going to plot them. Okay, so I'm going to start typing in RES, and you can do resid or residuals. I want to do residuals of, I'm going to start typing in high school model. Again, you guys did this for the baseball project. Now I'm going to hit enter. Oh my gosh, it's a list of 88 residuals. Okay, so thankfully R can help me order this. So I'm going to then order. This is key. I'm going to order my residuals for the high school model. This is so sweet. What this is telling me, and this is talking about, this is guideline, no. Yeah, this is all guideline 3, okay, which this is the second part of guideline 3, which is 30 points. We're going to comment on our 5 most over and underperforming towns in all 3 models. Town 76 is my most underperforming. So when you write underperforming towns, town 76 is number 1. Town 84 is number 2 for underperforming. Town 71 is 3. Town 56 is 4 for underperforming. Town 26 is 5 for underperforming. Town 21 has my largest residual, and you can go up and we can look. Town 19 is my second. Town 74, you can see right here. So this is 74, right under it. Town 74 is a residual of 44, 1,742 and 96, round to the nearest penny. So that makes sense. So they're my third highest residual. Town 29 is my fourth. Town 50 is my fifth. All right. Excellent. And then, okay, then we're going to plot. We're going to plot my residuals. Plot residuals, and I'm going to be kind of quick then on the other 2 models of high school model. Enter. There it is. There they are. So this is my first town. So this is Litchfield. That's Litchfield's residual. Okay, and this is town 88 over there. So my highest residuals, my lowest residuals. Where's town 1? Is Litchfield that? What was Litchfield for my high school model residual? Town 1, yeah, negative 19,000. Okay, almost negative 20. All right, folks, we're going to do the same thing here, only we're going to do, so I'm going to do college model. I'm going to do college model, and I think you should write like that. Don't leave a space. Linear model, so first off, less than dash. Linear model where y space tilde has a relationship with x2. I hit enter. Okay, if I go to my global environment, I got no error message. If I go to my global environment, now in data, I have the college model up there. Okay, now I want summary. I'm spell it correctly. I want summary of my college model. Summary college model. I hit enter. So this is it right here. So I'm going to say y hat is equal to 1682.1 x2 plus 41,841.0. It's my y-intercept. R squared is 0.6371. R is the square root of that. All right, it's positive because I have a positive slope. That is your regression model right there. Okay, I'm going to type in residuals. College model. I hit enter. Look at all those residuals. Then I'm going to do order. Residuals. College model. I'm going to hit enter. All right. This is my most overperforming. They're number 1. That's my second most over. Third most overperforming. Fourth most overperforming. Fifth most overperforming. Again, town 44 is a town name. I have to list them out with their residual. Town 10 is my most underperforming. Second most underperforming. Third most underperforming. Fourth most underperforming for town 76, which you can see the residual right here for town 76, negative 25,000. That makes sense. And then town 68 is my fifth most underperforming. Town 68 is right here. You can't see it yet. Town 68, they have a residual of negative 22,920.77. You're going to list their town name and their residual. Excellent. All right. And then, gosh, I should know that. What did we do? What did we do last? We made a plot. We made a plot of residuals of college model. All right. There you go. There's plot. Awesome. Lastly, we're going to do what I call just model both. Model both. Capital M, capital B. Less than, dash, linear model, parentheses, y now, tilde, has a relationship with x1 space and x2. You put the plus sign. Put the plus sign there. We're going to hit enter, okay? So if, again, sorry, you go up here. See, model both is now in our global environment. Yay. All right, I want a summary of model both. Summary of model both. Now I hit enter. Now this is very important, folks. I get both here, okay? So here's my model. My model is going to be y hat equals 560.3 x1 plus 1518.4 x2 minus 5353.3. That is my model. Now, because, guys, I have two predictor variables in here, we're going to use the adjusted R squared. Because, honestly, anytime you add a predictor, R squared is going to go up automatically, even if your predictor is weak. So I'm going to use the adjusted R squared. For the model both, you use adjusted R squared. Anytime you're talking about multiple linear regression, it's adjusted R squared. So I'm going to say R squared is 6.6369, and R is the square root of that. Obviously, yours is going to be a little bit different. Okay? Awesome. You use adjusted R squared for model both. And you go through the same thing here, folks. We're gonna talk about residuals. Type in residuals. Model both. Enter. Then we're gonna order the residuals. Order. Residuals. Model both. Enter. Again, we kind of the same towns. Then we are going to, we plotted, right? Plot, residuals, model, both. Enter. There they are. Folks, if we get all that typed in, we get those linear regression equations written down, we're going to be great shape. Great shape for Thursday. That gives us 2 full days to write out, type out what this means, copy and paste correctly, and analyze it well. All right, folks, thank you for having this ready, and thank you for taking care of business. This is Yak Math Videos signing out.